Hi, this is Mrs. Doris. This is lesson 9.3 entitled Solving Quadratic Equations. In this lesson, we will solve quadratic equations by graphing and also by using square roots. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a is not equal to 0. This form is called the standard form of a quadratic equation. Now, this may seem like you've heard this before, and you have, except when we initially talked about this quadratic form, we called it a function, and rather than the 0, we had a y there. When we replace the y with a 0, then we call it a quadratic equation. The solutions of a quadratic equation are the x-intercepts of the graph. X-intercepts of the graph are also known as the roots of the equation or the zeros of the function, or typically they're called the solutions of a quadratic equation. All right, so here you can see we have three possibilities for our number of solutions. A quadratic equation can have 1, 2, or no real number solutions. So in this first graph, you can see that this parabola crosses the x-axis at one point. That's where we're going to have one solution. In this case, we would say the solution is x equals 2, since it crosses the x-axis where x is 2. In our next example, where we have two solutions, it crosses the x-axis at negative 2 and at positive 2. So we would say our solutions are plus or minus 2. And in our next example, the parabola does not even cross the x-axis at all. So there are no x-intercepts, therefore there are no solutions. Solving quadratic equations by taking the square root. If a quadratic equation is in the form of x squared equals c, you can solve it by finding the square root of each side. Many times in a real-world situation, the negative square root may not be a reasonable solution. For instance, in the box, negative 7 1/10 would not make sense if you were finding the length of a window. All right, our example, you can see we have x squared equals 50. Taking the square root of each side, the square root of 50 is both a positive 7.1 and a negative 7.1. Now, 50 is not a perfect square root, so this is an approximation. Okay, problem 1, solving by graphing. What are the solutions of each equation? Use a graph of the related function. Okay, we're going to graph this equation, and to do that we want to write the related function, meaning we're going to replace the 0 with y. Our vertex of this graph is going to be at 0, negative 16. This goes back to lesson 9-1. The negative 16 we can see in the function. And because there is not a bx term, our axis of symmetry is at x equals 0, which is the y-axis. So let's begin our graph. I'm going to put my y-axis right here. I'm going to put my x-axis right here. And to get to negative 16, we're going to go by, let's see, I bet I can't go by 2's now. Let's go by 4's. So here's negative 4, negative 8, negative 12, negative 16 would be right there. Okay? And my axis of symmetry, of course, is along this line. All right, and I'm going to label my point since each square represents 4 units. So 0, negative 16. All right, let's make an XY table and graph just a few points. Let's pick x equals 1, x equals 2. We'll go ahead and pick x equals 3 and 4. All right. I'm going to erase a little bit of this here just to make room for some computation. And so we're going to select 1. What if x was 1? We would have 1 squared minus 16. So to get our y, 1 squared is 1, minus 16 is negative 15. So when x is 1, y is negative 15. And so negative 15 would be right about here on our graph and reflecting it across the axis right about there. Let's replace x with 2. We would have 2 squared minus 16. 2 squared is 4. 4 minus 16 is negative 12. So we're going to add 2, negative 12 to our xy chart. And plotting that point would be at 2, and negative 12 is right here. And we'll reflect that point across the y-axis. Let's replace it with 3. 3 squared minus 16. 3 squared is 9. 9 minus, let me rewrite that. 9 minus 16 would give us negative 7. So 3, negative 7 will be on our chart, and that would be right above this line. And let's, again, reflect it across the y-axis. And finally, let's go 4 squared minus 16. 4 squared is 16, and 16 minus 16 is equal to 0. Well, you'll notice that's what we had in our equation. So at 4, 0, we have a point, and reflecting it across the y-axis also gives us negative 4. So I'm going to use these points to draw my curve, my parabola, and my solution in answer to the question would be x is equal to positive 4 and negative 4. In our next example, we have our axis of symmetry, because there is no b term, is x equals 0. Our vertex is going to be 0, and in the equation we see positive 6 for our y. So 0, 6. This is going to go up, so I'm going to put my x-axis down here, and I'm going to put my y-axis kind of down the middle, and I'm going to plot my vertex, 0, 0. And just for a different color so we can kind of see, here's my axis of symmetry along the y-axis at x equals 0. All right, let's rewrite. I'm going to erase this to make some room. I'm going to rewrite my equation as a function. So I have 3x squared plus 6 is equal to y. All right, let's make an xy table. And we're going to choose some values of x and put them in to solve for y. So let's pick, and we don't need any points. We actually know what our solution is. So I'm going to pick just a couple. Let's pick 1. 3 times 1 squared plus 6. This may be the only one we can get on our graph anyway. 1 squared is 1. 3 times 1 plus 6 equals y. 3 times 1 is 3 plus 6 is equal to 9. So when x was 1, y is 9. So at 1, 9, right here, and also right here. Now, I can see I'm not going to get anything more. This is going to be a very, very skinny parabola. And my solution, however, I knew right at the beginning when I plotted my vertex. This is where it crosses the x-axis. So x equals 0 is the solution to this equation. Okay, in our next one, what are the solutions of this equation? Well, first of all, notice we don't have a 0 here, so we want to make that equal to 0. To do that, we're going to have to add 25 to it. And let me erase this line. I don't want you to think we're doing division here. We're going to add 25 to both sides. Now I'll draw my line. And negative 25 plus 25 is equal to 0. So I have x squared equals to 0. Writing the related function, I would have x squared equals y. So let's just make a little xy table. This one is a very simple one to do mathematically. Once again, my vertex is going to be at 0, 0 because I do not have a b term in this quadratic equation, or this quadratic function, I should call it. Let's put in 1. 1 squared is equal to 1 for our y. 2 squared is equal to 4 for our y. So let's plot these points on the graph. And once again, I'm going to draw my x-axis down here, my y up here, and plotting these points. We have 0, 0 right here, 1, 1, reflected across the axis of symmetry, 2, 4 right here, and I'm going to connect my points. Now, I realize at this point I made a mistake on the previous graph, so we'll go back here and fix it in just a moment. This one, I do have a solution of 0, 0. So my x equals 0 would be my solution. Okay, let's go back. I made a big mistake here. My vertex, and I may have said it and then I erased it before I plotted it and I put 0, 0. My vertex is at 0, 6. So all we need to do is erase part of our graph. All right. Our 0, 6 is going to be, replace my axes here. All right. 0, 1, 2, 3, 4, 5, 6. My vertex is right here. All right, so here's what we need to say on this one. Our solution is not x equals 0. Our solution is no solution. There is no real solution that will make this quadratic equation work. The reason why is because it does not cross this x-axis down here. All the points are up here. So when it does not cross the x-axis, we have no x-intercepts, which means there is not a solution. All right. Now let's move on to problem 2. And this is the best way, I think, of solving some of these simple equations, similar to ones that you saw in lesson 9.1. We can solve them using square roots quite easily. So what we want to do is we want to isolate m. So the first thing I'm going to do is add 36 to both sides. Negative 36 plus 36 is 0. So on the left side, I have m squared plus 0 is simply m squared. On the right-hand side, 0 plus 36 is 36. And now I want to take the square root of each side in order to get m. The square root of 36 is 6, both positive 6 and negative 6. Please remember to take both the positive and the negative. If we were going to do a quick sketch of the graph, our vertex would be down here at 0, negative 36, and it would cross the x-axis in two places. It would cross at positive 6, 0, and it would also cross at negative 6, 0. So we want to make sure that we include both solutions when it is a mathematical equation. So negative 6 and positive 6. In our next problem, the first thing I would do is subtract 15 from each side. I want to isolate my 3x squared. 0 minus 15 would be negative 15. And now let's divide by 3, remembering that our object is to isolate x. All right, I want to take the square root of each side. Now, here we have also a problem, because x is the square root of negative 5. If you put this into a calculator, you're going to get a message that says domain error. The reason that you get a domain error is there is no real number such that when you multiply it times itself, you end up getting negative 5. So here we would say x, actually I'll just take this away. There is no solution. And I should say no real number solution to this equation. All right. So when you get a negative number under a square root, that will be your answer. No real solution. All right. Our last example. Here we're isolating d, so I'm going to subtract 16 from each side. I end up with 4d squared is equal to 0. Dividing both sides by 4, I end up with d squared is equal to 0 divided by 4 is 0. And when I take the square root of each side, I get d equals 0. So notice we have an example here of one solution. That solution is 0. In green, this equation, we had two solutions. The middle equation in blue, no solution. And in red, on the right side, we had one solution. D is 0. Okay, our last problem in this lesson is about designing an aquarium for a new exhibit to showcase tropical fish. The exhibit will include a tank that is a rectangular prism. So I'm going to draw a picture of a rectangular prism, and we're going to label the parts. It says with a length that is twice the width. All right, so if I use W for my width, my length is going to be twice W, 2 times the width. The height is to be 4 feet, and the volume of the tank is 500 feet squared. What is the width of the tank to the nearest tenth of a foot? All right, so let's set our equation up. First of all, we want to recall that the volume of a rectangular prism is equal to the length times the width times the height. So replacing volume with 500 that's given to us in the problem. Our length is 2W, our width is W, and our height is 4. Simplifying the right-hand side of this equation, 2W times W times 4. 2 times 4 is 8. W times W is W squared. To isolate the W, we want to first divide by 8. 500 divided by 8 gives us 62.5 is equal to W squared. Then we want to take the square root of each side, and we get plus or minus 7.9 for W. Now, this is an example where we want to look at our solution and realize that when it comes to width, we can't have a negative number for width. So our actual width, we will just want the positive 7.9. And since we're dealing with feet, the width would be in feet. All right, if you have any questions, please don't hesitate to bring those to me or feel free to email me. Thank you very much.